Okay, I think we should go ahead and get started. Hello and welcome to today's CNCF webinar, Developing an Effective Observability Strategy for Your Kubernetes and Service Mesh Environments. My name is Baruch Sadogurski. I'm the head of developer relations with JFrog and a very proud CNCF ambassador. And I'd like to thank everyone who is joining us today. We would like to welcome our presenters today. Arijit, Mukherji.
Hello.
Hey, Arijit. Maxime, Petazzoni.
Hi.
Hi. And Yan Yu.
Hello.
And they are respectively the CTO of SignalFX, software engineer at SignalFX, and sales engineer at SignalFX. So welcome, everybody.
Hello, everyone.
Yep.
Yeah, sorry. Go ahead.
No worries. Before we start, just a couple of housekeeping items. As you already noticed, all of you are on mute, and that's to ensure audio quality. It doesn't mean that we don't want to hear from you. The opposite is right. We do want to hear from you, and there are two channels for that. There is a Q&A button in your Zoom panel, and that's for the questions that we will try to answer as much as possible live, and whatever we won't have time to answer live, we will answer afterwards in a follow-up email. So that's kind of about the questions of the topic of the webinar. And there is a chat window or button for everything else, like audio quality, or there is no sound, or anything like that. So Q&A for questions and answers towards the end, and chat for everybody else. We will also send you the video. Session is recorded and will be sent out afterwards along with the link to the slide. And with that, I'll hand it over to Arijit to kick off today's presentation.
Thank you, Baruch, and hello, everyone. Again, this is Arijit from SignalFX. I'm here with my coworkers, Max and Yan. So SignalFX is a company that provides monitoring as a SaaS service for these kind of environments that we're going to talk about. So let's talk about an effective observability strategy for these environments. What should you be thinking about? So we have a few things to cover. We're going to talk about why observability, sort of frame the problem a little bit, and what makes it challenging for cloud-native environments. How does Kubernetes allow itself to be monitored? How should you be thinking about that? And then lately, distributed tracing is becoming more and more of an important aspect of our observability strategy. So Max is going to talk about that. And then we're going to end with how a service mesh might help us. But it's not all going to be talk. We're going to have Jan do a demo near the end to talk about some of the principles and best practices that we're going to hit on to show you what that means. So hope that makes sense. So why observability? It really provides us sort of these three things. In general, it allows us to understand how my infrastructure, my applications are behaving and why. It allows us to do data-driven decisions, right? So it's not just for monitoring and keeping the lights on. It has many other purposes, which we will go into. But we're not always looking at charts and dashboards on the screen. So alerting allows us to be notified when things are not right. So for example, if my service level objective is being breached, by alerting on my SLIs, I'm able to notice when that happens. That's very important because unless I know something is wrong, how can I go and fix them? So not only do we need high quality alerting, it needs to be timely, because otherwise, I mean, this world of SaaS services and whatnot, where everybody is providing SLAs, you need your mean time to resolution to be as low as possible, right? Speaking of mean time to resolution, when you do have a problem, how do you know where the problem was or what the problem was? So again, observability helps us get clues into that. So it is pretty broad, and it gives us a lot of different aspects that we require to run our infrastructure and applications. Now, if you are thinking about an observability strategy, you have to have all these different aspects of it in place. You must have logs, you must have metrics, and you must have some way of transaction profiling and distributed traces along with your monitoring system. You typically won't be able to really be effective if you had just one or two of these, for example. Now, there's a little bit of confusion in the industry because logs can produce metrics, or traces can be considered as logs, and so on. But in general, these three technologies, these are the pillars, and they do provide three different aspects of the information that you need. So when you're setting up your strategy, you must think about all of them. So how do we think about them, right? We think of metrics as the sort of the canary in the coal mine. This is the thing that's telling you from a high level how things are doing, and it's allowing you to get alerted when things are off. So they are sort of anonymized in the sense that they don't give you the specific details, but they tell you when something is off. That's metrics. Do I have a problem? But then where is the problem? Our environments are very, very complicated now. Like we have so many different microservices and complex dependencies. So understanding where the problem is, that's where distributed tracing helps us. But then even if I knew that my microservice blah had a problem, what was the specific problem? What was that error? What was the exception? And so on. So that's where logs come in. So they give us the sort of the forensics that we need to understand what's going on. And obviously a monitoring system sits on top of these, and it provides us the monitoring capabilities on top of the data from these. As I mentioned, observability has many, many different use cases. It's not just about the monitoring incident response, so on. It can help you with testing. So for example, if you're doing A/B testing, you want to know how version A compares against version B. Well, how do you do that is by observing both these releases and by seeing how they compare with each other. Capacity planning is also interesting. Typically, when we think of observability, we may think about short time periods, what happened in the last hour or day or so on. But there's actually far more important other use cases too. For example, with capacity planning, if I had a trend of how your infrastructure and applications have been behaving over time, then you know that, well, based on the trend, maybe I'm going to have so many X more requests, or my resources are getting used up. So how do you capacity plan? How do you decide how much infrastructure to deploy? So that's observability can help you with that. Developers, as they're developing new features, again would use all these systems to understand whether the code that they're writing is perhaps performant or whether it's accurate and so on. So overall, observability is not just for the day-to-day operations, it is for far more, right? So, but you're probably not doing all of them right now, or maybe some of you are, and maybe some of you are not. So what's the observability maturity curve? What does good look like in this space, right? So typically, this is the curve that we got from Gartner, and I think I agree with this in the sense that it starts off with the basics. It starts off with infrastructure, and starts off with monitoring your cloud services. At that point, more as black boxes. But then at some point, you realize that, well, my infrastructure is interesting, but my own application is more interesting. So I need to start monitoring that. So that's when you might say, let's say, use a traditional APM tool, which is instrumenting your code and giving you insight into that. But as an organization matures, you will find that they start adopting DevOps methodologies, and that's where the developers start having a say in this. They start instrumenting their application to produce the things, to produce the telemetry that they then depend on to make sure that they're able to operate it well. Because our environments are large and complicated, because we have way more containers than we used to have servers back in the day, without automation, it's not something that you can scale. We cannot have enough humans to man every single page that you might get. So automation becomes very key, where you're able to handle all the usual non-interesting alerts automatically and have the humans do the stuff that really requires the humans to be there in the first place. A similar idea is AI ops, or artificial intelligence driven ops. The idea there is you want to use data science and machine learning to have your observability system even make sense of your environment. Because even if I said, well, I'm going to monitor service X, what thresholds should I set? Even that can be complicated in a highly dynamic environment. So with AI ops, you're able to have the system learn its behavior and then do the right thing and set the right alert for you, right? And then obviously the last stage is business, where we are all in various organizations. They have a purpose, they have a business purpose. How do we tie that back into all of this stuff that I talked about? For example, how many products did I sell? How many failures in the cart happened? And how do I tie that into what I'm monitoring? So that's sort of the maturity curve. You obviously cannot go from the stage 1 to the stage end right away. There has to be some level of you need to follow the steps, so to speak. You got to walk before you run. I feel that an organization needs to be in one of these stages for a little while to sort of stew in it, to get the engineers used to it before they realize the importance and how to do the next steps well. So in terms of where you would want to go, what good looks like, this is a pretty good indication of that. So let's talk about metrics. So in general, I mentioned logs, metrics, and traces. In this talk, we're going to primarily focus on metrics and traces. Suffice it to say that logs are also very important, and you must have a good logging infrastructure set up, but that's not the part of the discussion today. So when we talk of metrics, what metrics are we talking about? Where are these metrics even coming from? Luckily or unluckily, there are many different sources of them. Lucky because you get a lot of data, and unlucky because you got to collect them. All your stuff is running on hosts and virtual machines, so you got to monitor those. Those things are running containers, so you got to monitor those. The containers are running my applications or third-party OSS like Kafka, Elasticsearch. You got to monitor those. They're running in a cloud environment, so you got to monitor the cloud infrastructure from what it gives you. The business metrics we talked about, of course, but wait, that's not all. I mean, if you have an APM system, if you have logs, you can create metrics out of those too. So really, when you are thinking about a metric strategy, you need to think about this holistically. You need to be able to collect all of this together, because otherwise effective observability may not happen. So then it may feel like a tall task. So how would you then collect metrics? What metrics would you collect from these places? So here are some best practices and methodologies for how to collect metrics from these different systems. If it's a resource, for example, like a disk or a host, you might use the use method, utilization, saturation, and errors, where it tells you, how much a resource is used, how much backlog it still has to work through, and how much errors are happening. Another good one for your own applications, which are not sort of resources, perhaps like things like APIs, is the RAID method, or rates, errors, and duration. How many calls am I having? How many of them are failing? And how long are those calls taking? Because that way, a lot of issues may not have to do with errors, but more with latency. So this captures it very well. Google SRE, follows the 4 golden signals, as they call it, which is latency, traffic, errors, and saturation, which is kind of similar to these other ones. And there's, of course, there's business metrics. So the important thing here is you must have a standardized strategy. More than which specific methodology you use, engineers need to frequently look at other systems or adjacent systems. Unless you have a standard, then you may not maintain a base level of quality. And at the same time, they may not know what to expect when they're looking somewhere else. So having a standard makes a whole lot of sense. So now let's say you're going on this cloud native journey, you've taken your monoliths, you've broken them into microservices, you're adopting DevOps methodologies. Chances are you're going to use Kubernetes, because looks like, and I'm happy that the Kubernetes seems to have won the cloud orchestration war, or not, whatever. And but if you look at monitoring of Kubernetes, if you look at what are the main challenges that people are reporting, and this is from a CNCF survey itself, 38% of organizations said that monitoring is the biggest challenge, because Kubernetes is not simple. Our cloud native environments are not simple. And if you look at the larger enterprises, that number actually grows up. And the reason is, larger enterprises have to deal with way more other complexity. They have perhaps deployed in many regions, in many clouds. There are probably many more microservices. They're using many more languages. They have many more users. So this gets harder and harder, right? And the reason monitoring a Kubernetes environment, while Kubernetes gives us a lot of good things out of the box, it's also a more complex thing to monitor, because we have to monitor every single layer that I talked about. You got to monitor the microservices, your applications at the top. They're running on the containers. You got to monitor those. You got to monitor the Kubernetes platform itself, and then obviously the substrate, the infrastructure on which it is running on. So all of this needs to be done, and needs to be done well. So let's look at the Kubernetes orchestrator itself. Look at how many different subcomponents it has, right? Now, that might feel like a tall order, and obviously you don't have to be an expert in all of these, because frankly, it's the job of the orchestrator to take care of much of this for you and abstract it for you. But there are still certain basic primitives that you must be aware of, that you should be able to monitor. For example, there's a master that's doing all this orchestration. It's deploying services as deployments, so you got to be able to have a control on those. The deployments are happening in multiple pods. The pods contain containers. The pods are running on nodes. So there's a bunch of these primitives that you must be able to monitor and get metrics from, if you're talking about metrics. Now, luckily, the Kubernetes project itself has thought about observability from the ground up, and all of these subsystems, they make available telemetry and metrics for you, and they also do it in a standardized fashion. So at least the job of creating those metrics, etc., is done for you. You have to collect them, and they make them available in a standardized format, the Prometheus exposition format. And Prometheus is actually the second project that graduated out of the CNCF after Kubernetes itself, which tells you how important observability is to the ecosystem. Prometheus is a time series monitoring system, and it has very good qualities associated with it. It's multi-dimensional, which means that you can pull in all these labels that Kubernetes applies to the various resources and use them to color the metrics that you are looking at. It has deep Kubernetes integration. As I said, every single component makes Prometheus readable metrics available for you. And it also supports all the multiple layers. You can go and observe all the different layers that I just talked about in the past. So what are some of the ways to collect metrics from these different layers? So if you were to start off with monitoring metrics on a Kubernetes environment, you obviously deploy Prometheus. In order to get the data from the nodes themselves, like CPU, memory, etc., from the nodes themselves, there's a process called the node exporter, which you can run as a daemon set on all the nodes, and that's going to get you those metrics. If you are running third-party OSS apps, there are various other Prometheus exporters that run as a sidecar along with them, for example, Kafka, and which will make the metrics from those systems available to you in a Prometheus readable format. On the containers themselves, the kubelet process that's running on the nodes, it has a C-advisor built in, which will give you information about the containers in there. Then there's the orchestrator itself makes many other what are called kube state metrics available to you. So these are metrics that are created by grokking the state of the Kubernetes orchestrator. For example, how many pods, how many nodes, how many containers in a pod, how many pods in a deployment, and so on. So it parses that metadata and makes metrics out of it. So you need to be able to get all of this into your system. And then if you look at your own application code, it has libraries in all the major languages so that you can instrument your code to report counters and gauges and histograms and timers and what have you. So it's a pretty well-defined and complete ecosystem in some sense. Once the data is in there, you're able to process them. You're able to analyze them. Prometheus has a language called PromQL, or Prometheus Query Language. And as the example here shows, you can do various things like transformations and mathematical operations. You can combine metrics and do various other interesting things. So this will allow you to have higher level observability and alerts. But there's also some challenges with it. It's obviously, it doesn't have any visualization, so you're probably going to use Grafana. It does not have security and authentication, etc., built in, so you'll have to figure that out if that's important to you. In terms of long-term storage, it starts getting interesting because it uses the local file system. So typically, you may not store a very, very long amount of data in it. And then it's also not a full-fledged monitoring system. It's just for metrics. So it's not going to tell you things about the dependencies among your microservices and so on, right? So if that happens, you can obviously decide to build some of these functionalities on your own, or you can use sort of other sort of vendor solutions and so on, which there's a pretty healthy ecosystem around there. For example, SIGNALFX has also a pretty good Prometheus and Kubernetes integration built in. At this point, I'm going to hand it over to Max, who's going to talk about another aspect, which is the distributed tracing and transaction monitoring.
Thank you, Arijit. So as you said, metrics are a very important contributor to your observability strategy. They're easy, they're fast, flexible, and they can give you a lot of visibility into the activity, the behavior, and the performance of your applications. But what it falls short really is providing you that end-to-end view of application performance that goes across all of the back-end distributed systems that are involved in answering user requests. They're by nature siloed and require the operator to know how all of the application stack is architected and connected together to track down the root cause of a system degradation. Distributed tracing is ideal for this use case. So this tweet here on the party account on the status page went viral a few years ago because it really rings true. It's a particularly humorous take on the challenge of monitoring and operating microservices at scale. As we start to break up our old monolithic applications into more flexible and elastic architectures with microservices, functions, etc., it becomes really difficult to make sense of traditional monitoring systems like metrics and logs. They lack context, and they're often not sufficient to triage and to determine root cause across service boundaries. Distributed tracing, on the other hand, captures application performance information across all the services involved in a transaction, preserving that context and the knowledge of service dependencies. So why distributed tracing? Back to fictional company Acme Corp, their backend is made up of several microservices and systems that communicate with each other. For example, the front-end web service calls into their application and their authentication service, which in turn calls into an account service that looks up account information into a profile database. If that database starts having issues, and all the upstream services in that chain will start to experience that degradation, multiple ladders might fire, and the end users will start to deteriorate. The end user experience. So troubleshooting this type of issues is not easy. And if you're to rely solely on metrics, it would require a lot of tribal knowledge about how all of those services interact with each other to understand that the database degradation is the real issue here. Distributed tracing, on the other hand, by capturing application performance information at the transactional level, gives you an end-to-end view of how a particular request was handled through all those services. Where the time was spent, what was the call chain, were there timeouts and errors, etc. Even without any architectural knowledge, identifying the root cause of an endpoint's degradation becomes trivially simple with tracing. So how does tracing work exactly? Tracing works by capturing the operations involved in the handling of a particular request and propagating the context of the current trace to the downstream services so the operations that they too capture can be assembled into that same trace. Those steps or operations captured in trace are called spans, and they can be represented in a call tree like the one shown here on the right. OpenTracing is a CNCF project that defines the semantics and programming interfaces for distributed tracing. It also offers a broad collection of instrumentations for commonly used open source frameworks and libraries that you may be using in your applications. This helps you improve the coverage and detail level of the traces you capture from your systems. Additionally, OpenTracing is helping to define the standard for context propagation called B3. How context propagation happens depends on the communication protocol that you use between your services. For example, for HTTP or gRPC calls that might be done using HTTP headers. But that standard doesn't really aim at defining that implementation detail, but more at defining the semantics of those additional fields that are exchanged between services. And this context propagation standard is a really important component of distributed tracing because the interoperability between services written in essentially different languages, using different tracing libraries, is what ensures the trace can continue through downstream services to provide the full end-to-end picture. Tracing is a really powerful mechanism that plays a key role in providing an effective observability platform for your engineering teams. From our experience at SIGNALFX as a technology company, and from what we've learned from our own customers, there's a few high-level challenges that you need to watch out for. We'll see in a moment what good looks like for those challenges and what that looks like in practice in the demo that we have at the end of the webinar. The first one is about sampling. Trace data is much more complex and detailed than metrics, so there's typically a higher cost to storing a large volume of traces. Depending on the volume of requests handled by your application, you might only want to store a fraction of the traces. Using head-based sampling, where the decision to record and keep a trace is made at the beginning of the transaction, you'll routinely miss important traces, those that represent errors or response time outliers. It's effectively up to blind luck, and it can make it really difficult to troubleshoot intermittent issues. The next one is alert fatigue. A monitoring system that considers its input signals in isolation with no knowledge of the relationship between services will typically lead to alert storms caused by the cascading nature of failures in distributed systems. Triaging and root cause isolation are the top priorities in incident response. You need to make sure that your tracing solution actively helps you reach those goals instead of making them harder, leaving you in a needle in the haystack scenarios that prolong your MTTR. Finally, a distributed system that is siloed from the rest of your application and infrastructure monitoring will be limiting your insights and root cause investigation. So what does good look like? What are the key contributors to an observability strategy that deliver compound value for your organization? The first thing is tail-based sampling for your traces. By recording and analyzing 100% of the traces and making a smart sampling decision where the trace is assembled, you can dramatically improve the quality of the tracing data that you have at your disposal without increasing your storage costs. With tail-based sampling, you can intelligently select interesting traces that are worth keeping, those that represent response time outliers, those that contain errors, etc. Next is by connecting your monitoring and alerting systems with the rich dependency knowledge that is inherently provided by your distributed tracing data. This allows you to build smarter alerting that can automatically mute alerts on upstream services when the root cause is really with that database at the bottom of the call stack, while giving you detailed context and impact information along with the alerts about that database. You also want a monitoring solution that doesn't just tell you when something is wrong, but goes further and actively helps you investigate the issue and find the root cause. Metrics and trace metadata provide a lot of opportunities for data science and directed troubleshooting that will significantly reduce the time to clue and ultimately your MTTR. Finally, a single pane of glass that collects all of your monitoring data and help you navigate both horizontal dependencies between your services, but also vertical dependencies through all of the layers of your application, containers, orchestration platforms, and infrastructure, again, helping you identify if your root cause is in your application or in your infrastructure. So to better illustrate the difference between head-based sampling and tail-based sampling, here are the results of an experiment that we did in which we fed the same data set of traces through a random head-based sampler on the left and through an intelligent tail-based sampling algorithm on the right, but with the same target retained volume. The first thing to notice at the top is that head-based sampling was virtually unable to capture any of the traces that contain errors. It's not surprising since the sampling decision is random, but it's incredibly unhelpful. Traces that contain errors are extremely valuable in troubleshooting system issues, especially ones that are intermittent. And at the bottom, we can see that tail-based sampling is able to select traces much further into the long tail response times where the interesting P99 above traces happen. Getting started with distributed tracing is probably the biggest challenge. As we've seen, there's a lot of value in bringing trace data in your monitoring system to power your troubleshooting, your investigation workflows, and smarter alerting. Thankfully, OpenTracing and Jaeger, another CNCF project that provides a tracer implementation of those OpenTracing APIs, help you instrument your systems, whatever your application stack might be like. And service meshes in particular are uniquely positioned to capture and report metrics and tracing telemetry about your entire microservices architecture. Istio, Linkerd, or Envoy, another CNCF project, and others all provide powerful monitoring fundamentals. And with that, I'll hand it back to Arijit to tell you more.
Cool. So I wanted to touch upon service meshes a little bit. This is an area that's getting a lot of interest lately. There's been a lot of momentum behind them. Obviously, we have Istio and Envoy and whatnot, which are sort of powering some of this out there in the wild. And from a monitoring and observability perspective, they actually bring a lot to the table. So if you're an organization starting off with setting up new infrastructure, writing new applications, we feel that you should consider service mesh, especially as it comes to observability and monitoring. The first thing that it helps us with, which it makes our lives easier in some sense, which is kind of why I'm doing this shameless plug. In general, because service mesh is deployed throughout your microservices and it is looking at interactions between every single microservice to another, it is out there and it can go and monitor these interactions for you without you having to do a lot of stuff. For example, it can know that in any time a service A calls a service B, well, the service mesh itself can then create metrics and telemetry from that. So you get what we call a breadth of coverage, which just comes for free as a result of deploying a mesh like this. The other thing that it brings is that standardization we talked about in the past of having a standard methodology for collecting these. Well, the mesh can do that. So what it could do is, for example, for every API call going between services, it can capture red metrics and it can report them to your monitoring system, which is also great because now I do not only have breadth of coverage, I also have a minimum bar on the kind of telemetry that I am collecting. So, for example, to make that more apparent, so this is sort of a picture of a typical environment. Let's say you have a host is running a bunch of containers, they're generating all kinds of telemetry, and these proxies that are running on them, they are able to be an aggregator for much of this telemetry and then forward them to your different metrics and observability systems for you. So we feel that if we want to have high quality and widespread collection of observability data, having a service mesh in place definitely helps make that job easier. And really, I think in the file and run, we talked about what good looks like, where you're able to have automation come to bear and data science and whatnot. I feel that service mesh, having that standardized, high-quality, widespread data set in use lets us have what I like to call policy-driven operations, where I express my intent to my system, and it's observed by my observability system, which then gives me feedback about whether my intent is really being respected or not. And based on that, it can go and take automatic action. Now, it could be as simple as I want the host to be up, and if the host is down, I'm going to go and restart it, or it could be something far more higher level. But having a solid observability system in place with some standards, with some breadth of coverage, really enables us to go to these higher levels, and that's kind of when we as organizations are going to become far more efficient and fast moving and just better in general. So we're going to have now Jan, who's going to do a demo, and he's going to go over some of the principles that we mentioned in this talk, and hopefully that would make sense to you all. Thank you.
Thanks, Arijit. As we mentioned in this demo, we'd like to show you how to implement the best practices for monitoring Kubernetes environment with SignalFX. And from that, what I'm going to do is start with the infrastructure first and move up the stack from there. So here, what we're doing with SignalFX is that we've deployed our SignalFX Smart Agent across about 1,500 hosts in our infrastructure here, and we're now able to see individual metrics for each of these. In this case, we're looking at the CPU metrics for every single one of these hosts, but we could also be looking at memory, disk, or network. And additionally, down here, we're actually aggregating this and giving you percentile distributions and totals for the memory used, disk, network, memory. When looking at something like this in aggregate, it's not always helpful to see kind of everything all grouped together. So one of the things we can do is we automatically pull down a lot of the metadata from AWS and other orchestration services that we're using. And we can use this to either filter down the data further or to group it up into ways that make sense to us. So for example, we can take this AWS availability zone tag, use that as a grouping tool, and apply that. And now we can see how our hosts are distributed among different availability zones where we are deployed, in this case, primarily in the US East. We can also pull custom tags and labels from things like Kubernetes or AWS. And in that way, we can actually look at something, say, like a service tag that we use to actually understand the individual microservices within SignalFX's infrastructure. More than just being a visual tool to organize what you're looking at, we can use this as a filter as well. So we can click into this specific service, Metabase Elasticsearch, and actually see the aggregate metrics for those specific 300 hosts. So we can see the aggregate CPU, disk, and memory. And from this view, we can actually apply an alert as well. So if we wanted to monitor the CPU for these particular hosts, for this particular service, we could create a new detector from one of our built-in templates. For example, a CPU utilization % greater than historical norm. And that'll create what we call a baseline alert that looks at the preceding 24 hours of CPU utilization and sends an alert if the last 10 minutes more than 3 standard deviations above that. And this will apply to all hosts that are part of this particular set of filters. So as you spin up more hosts or as hosts go away, those will automatically be included or excluded from this alert. The recipients for this alert can be me, some email, some team, or one of our service integrations such as HipChat, PagerDuty, ServiceNow, Slack, VictorOps. Or if you're thinking about automation, something like a webhook, right, as Arijit mentioned before. So in assuming you did receive an alert, the question would be what you might want to do next. In the event that we receive an alert, we can actually dig into the specific node that triggered that alert and get even more detail. We'll be able to see the system metrics for that particular node, but also be able to understand the properties of that node as collected from AWS, from the agent itself, and any other properties that we added after the fact. Combining that with the processes running on that node as well, this helps an engineer understand what the problem might be without having to actually SSH into the box or actually access the box in any way. Furthermore, our agent, because it has all this information available to it, it's able to automatically instrument itself to collect metrics for the services running on the node. For example, in this case, we see that this node is a Docker host, so we can generate a Docker dashboard based on that information. And similarly, it's an Elasticsearch node as well, so we can see the Elasticsearch node dashboard specific to this particular node. So moving up the stack from thinking about infrastructure and applications, often what a lot of our customers are doing now is thinking about their service infrastructure from a services point of view. And so here, what SignalFX is able to do is to collect all these different traces and spans and combine those with infrastructure metrics to give you a view more like this, where now what we can see is the different services in our architecture and how they relate to one another. We can see which services are upstream or downstream, and we can actually see the request rates, error rates, and durations of the request to each of these services, the red metrics, as Arijit mentioned before. On top of that, we can actually dig into a specific service as well and see the different endpoints within that service. And for additional detail, we can go to an out-of-the-box service dashboard that SignalFX generates and see those metrics overlaid with infrastructure metrics. Here in this service dashboard for my API service, I can see the request rate, latency distribution, error rate distributed over time. So I can see if I'm trending towards some problem or if things are getting better. And as I scroll down further, I'm actually able to combine that with my host metrics as well. So if I am seeing some sort of problem, I can try and understand whether or not that relates to the host CPU, host memory usage. Maybe I'm doing some sort of garbage collection here that would be represented in those metrics. By having this as kind of a primary dashboard for understanding your services, this helps you identify quickly where the problem might be. In addition to these standard dashboards that we provide, you can also have custom dashboards as well. This catalog service here handles a lot of requests for this particular e-commerce application, and it handles those through these 3 different endpoints. And so for us to get a better view on what this service does, we've created this custom dashboard here with high resolution metrics that helps us better understand what's going on. Here, what we're looking at is the number of requests per container that's being cataloged by being processed by the catalog. We're also looking at the request latency that each customer is experiencing. And as you can see, these metrics are coming in at a 1-second resolution. So every second we're seeing an update of what's happening here. As an engineer, this is valuable because if what I want to do is to go ahead and make some sort of canary deployment, I can see the effects of that deployment immediately. So hopping over here to my console, I have a deploy script ready to go. And what it does is this goes ahead and talks to Jenkins and tells Jenkins to deploy the next ready version of my canary to this particular environment. Clicking that here, what we'll see happen here in just a second is that we'll see a custom event from that deploy script from Jenkins that lets me know that I have deployed a new canary. And then once that's done, we're actually seeing now the new container getting spun up, this new canary, and the old container being spun down. At the same time, we can see that this new container seems to have kind of high latency, which seems to be a problem. And as noted, it's happening at the same time as we push that canary. In the background, what SignalFX is doing is it's using its intelligence to try and figure out if there's some sort of anomaly with this new deployment. And what it'll find is that this high latency is triggering our population outlier alert. So what we're seeing is that this outlier is beyond what we would expect. And when that alert triggers, we automatically initiate an automated rollback. The SignalFX alert uses its webhook to talk to Jenkins and to say, roll back this canary and put back up standard production nodes so we do not affect the user experience too much. And so you can see here, after this event, we've spun down that canary, and now we're looking at a standard production deployment again. It's this kind of automation that Arijit was mentioning before that helps engineers have more impact in the organization and to do more with less. Once you've resolved this kind of alert, the next thing you might want to do is to understand, what caused that problem. Is there something I can do to prevent this in the future? One of the things we allow you to do, one of the things we enable is with our data links tooling, we can actually take a look at the container ID here, understand that's canary, and to issue a query into some logging platform using that information in that time frame. This is a good way of looking back to understand, what were the logs at that point in time? What is that telling me? Additionally, what we can do is we can actually take this time frame here and look at all the traces from this time window, which will give us a better insight into exactly the transactions that were happening in that time period and what everything else looked like in that time period as well. In this traces view, again, we're seeing this dependency map and understanding how the services relate to one another, but now we can actually see all the individual transactions that are happening in this period of time. Here we can see this latency distribution chart, which is showing us all the trace distributions from 1.8 milliseconds down here, or to the long tail of up to 10 seconds on the other end. We can also see the rate of requests that we received in this period of time, as well as the errors. In order to help sort through all this, one of the things we might do is to, rather than look at every individual one of these traces, we can actually filter these down further based on the information that we already had from before. In this case, what we might do is to go ahead and use our deployment filter and look specifically for the canary deployment traces. This helps us narrow down to understand specifically what traces were going through that canary deployment. And to get further information, we can actually click this Analyze Outliers button. This uses our statistical analysis and shows us specifically which operations and which services are contributing the most to the duration of traces in this time period. Clicking this applies another filter for the catalog service and the StockDB endpoint, which is causing a lot of delay in our transactions. And now we can actually see each of these individual transactions, be confident that's exhibiting the behavior that we're trying to solve. So clicking into this one here, now we're looking at the full map of a given trace with all the spans that are within it. Zooming in here a little bit, we can see which services we're looking at and which endpoints within those services that we're hitting and which operations we're running. And we can see here that there's kind of some long spans here, but what we don't necessarily understand is this normal or is this some error that's happening? One of the things we can do with SignalFX is we can actually take a look at each of these spans and color them by how they're performing in this particular instance against the historical duration. This will immediately highlight if we're seeing deviations from standard behavior within this trace. And we can quickly identify that indeed this long running trace here is running much longer than it ought to be. Getting additional information here, we can see that this is a canary deployment. It's running on this particular host. And we can see that we've actually added information about the query itself in here as well. And maybe what's happening here is that this long running query is actually causing the problem. Maybe this inefficient query is part of the canary and is making it so that we're seeing that long latency that forces us to roll that canary back. So as a developer, I can take this back to the team. We can figure out how to triage this and maybe avoid this problem in the future. So this has been kind of an overview of how to use SignalFX to have better monitoring and observability across Kubernetes applications.
Yes, thanks, Jan. So hopefully we were able to sort of demonstrate the importance of collecting data from multiple different layers, the importance of being able to correlate between those layers so that, when you have the problem happens, you need to be able to correlate across them. The importance of having distributed traces because they really help us with the triage process. We mentioned being able to look at logs. The other thing that I think was sort of maybe subtle is that the ability to go back and forth between your various monitoring systems is a very important thing because unless they are well integrated, a lot of times you may not get the value out of them. So, for example, being able to go from a metric to a distributed trace and back and forth between those systems. Those are the kind of qualities that as you are building your observability infrastructure that you should keep in mind about because these are the things that will make them more and more effective. We also sort of showed how automation is important and how that can help us be more efficient by allowing the computers to take care of many of our issues. We also showed you, if you look at, go back to the maturation curve that we showed in the beginning, we also showed the importance of having data science come to bear so that we don't have to manually set various static thresholds and such, but have our system learn and automatically identify alerts and outliers. So hopefully that sort of gives you a broad sense of what sort of we talked about in the beginning of the talk track section. And with that, we have one or two more slides, right? So let's go back to yes. So there's really not much in here, but in general, we wanted to show you lots of pretty boxes at the end. But in general, I think I mentioned much of these qualities. So having observability is not easy, especially good quality observability is not easy. You must be prepared to spend time and people and money or whatever the case may be to make sure that you have a good system in place. I hope we were able to make the case that there's many areas where it can help you. It's not just about taking a log and viewing it on a UI or getting a metric and seeing a chart for it. It's far more than that, and you must have a coherent strategy around it. And your observability system must have certain qualities which make it, which are even more critical in cloud native environments, especially with cloud native things are spinning up and down and elastic. So auto discovery is important. High resolution is important so that you're able to find problems quickly. Speed of data processing is important so that you can when a problem happens, are able to slice and dice relatively fast, because otherwise that might also slow you down. We talked about data science and analytics. We talked about dashboards. Precise alerting is key, because if you alert on too many low-level things, you're going to be drowned in alert noise. So being able to have high-quality, SLI-driven alerts is important. We talked about and we showed how end-to-end visibility is important. And the last thing is, as we sort of move to more and more cloud native and DevOps, what we find is, infrastructure and deployments driven by code rather than by humans. So your observability system must be able to deal with that. It must have APIs that you are able to use to programmatically deploy not only your infrastructure, but also the associated observability and monitoring. So it's a complex topic, but it's well worth it if you spend your time and set up something good. With that, we're going to end, and we're going to take any questions.
Thank you very much, folks. That was absolutely awesome. And, the demos were really demonstrating what you wanted to say. So thank you very much for that. We do fortunately have some time for questions, like almost 10 minutes, and there are quite a bit. So let's start with the simple one. Brian here asks, will this work in a Windows environment?
The short answer is yes. So that's actually interesting, because yes, our environments tend to be quite varied, different clouds, different operating systems. So the typical thing tends to be that you would have to have an agent that is working on a Windows environment and is able to fetch metrics from them. For example, the SIGNALFX solution does support the Windows environment.
Awesome. Okay. And here is another one. Is tracing tool included in the SIGNALFX tool, or is it using OpenTracing under the hood?
So CNCF-hosted Microsoft JVM solution is based on OpenTracing, right? We made a point from the beginning of make sure that we leverage open standards and the community of open source libraries and standards to make instrumentation really easy and compatible with what people have already done in their applications. So we do leverage the OpenTracing standard and APIs, and our solution actually recommends using the Jaeger tracer, which is another CNCF project.
Okay, and on the same VM, can it also use Jaeger instead of OpenTracing?
So OpenTracing itself only defines the semantic and APIs for distributed tracing. So you still need an actual tracer implementation behind this, and Jaeger is one such implementation, right? It is an implementation that implements those OpenTracing APIs. So those two really come together to actually provide tracing solution.
Right. And the next question is, how much, does SIGNALFX support integration with Spinnaker?
So it was
Spinnaker.
I'm not sure what that is.
That's in Netflix OSS tool. Well, okay. I guess this answer you will look into it and send a reply maybe with the follow-up email.
Yes. So in general, we do have a lot of integrations. I think more than 150 of them, and we do spin them up all the time. We have a team dedicated to doing this. So these are relatively easy for us to support, but again, it depends on the technology in question. But yeah, we can take this offline.
Yeah. Okay. This is great. Thank you. There are a couple of questions on the same, which is actually the same question. And which instrumentation and how much do I need to instrument my code in for the SIGNALFX agent?
So the answer is it depends. So for the most part, you would only have to instrument your code for your own first-party application. So, for example, if you use a host agent like a Telegraph or a CollectD and so on, or even the SIGNALFX Smart Agent, which is based on CollectD, they are able to fetch all your at least your node resource metrics, infrastructure metrics like CPU, memory, all of that by themselves. All of these have very good support for third-party OSS services, like all of the open source stuff that you have, like Kafka, Elasticsearch, MySQL, and whatnot. So they are able to monitor them as black boxes, and you can even then have them get exported to Prometheus or your monitoring system like SignalFX too. Where they won't do that is your own code, because there is no way for SignalFX to sort of, unless you're running an APM agent in the traditional APM agent, which is sort of like running within your process, you wouldn't be able to get the metadata or the metrics from within your application, but that you have client libraries to do. If you are deployed in a service mesh environment, maybe you won't even have to do that, because at least the service-to-service interactions might get automatically monitored on your behalf. So the short answer is, for the most part, for everything other than your own code, you probably don't have to do anything other than set up some configuration. And then for your own code, there may be agents or libraries that you might bring to bear.
Yep, that makes sense. And here is another one. Can SignalFX run on AWS and manage storage for metrics?
Yeah, so SignalFX does run on AWS. So we are actually a SaaS service. So we have effectively abstracted away all the stuff that happens after the metrics leave your systems and come to it. So in a way, you think of us as a Prometheus plus all these other stuff that we talked about as a service. So we handle the storage for you, we handle the scaling for you, and all of that. We handle the APIs, the alerting, all of that for you. And then the main thing that needs to happen is the metrics and traces, etc., need to come from your environment to us, for which we have smart agents and client libraries and what have you.
Yep. And it's a little bit similar to previous question, but a little bit different. Do we need to install a new agent on Kubernetes for OpenTracing? I think we kind of discussed it, but maybe just to make it a little bit clearer.
So it depends what the question means about the interaction between tracing and Kubernetes here. So if you're
especially for OpenTracing.
I'm sorry, go ahead.
Especially for OpenTracing.
Right. So if you're leveraging a service mesh in your environments, those automatically collect telemetry, both metrics and traces for you, and support reporting that to a destination of your choice. Then if you're talking about the applications that you're running, either on top of the service mesh or on Kubernetes containers directly, you have the choice of either using an application agent that can do a lot of automatic instrumentation for you, or to manually instrument your code using a lot of the open source libraries, like Jaeger that we talked about, that is an OpenTracing compatible tracer.
All right, okay. Another question, does SignalFX works only with Kubernetes, or will it work on virtual machine-based microservices deployments?
So it will work everywhere. So in some sense, it's a metrics and distributed tracing platform, and it does not have an opinion on where those metrics and distributed traces are coming from, as well as the metadata are coming from. What we have done is we have built integrations to various clouds and orchestrators, because they are the ones that are in currency that various teams and team organizations are using. But theoretically, you could have sent us weather data or stock prices, and we would monitor them just fine. So it's a generic platform, so it definitely obviously works with on-prem as well as other VM-based environments. All you need again is just either metrics and distributed traces to be sent to us, and we have again ways to collect them for you. But we do have very tight and well-defined integrations to the common public clouds and things like Kubernetes and so on.
All right, and I guess the last question that we have time to take live will be that you mentioned that larger deployments and organizations may move to commercial solutions for sophisticated do-it-yourself systems to handle their monitoring. What are some of the reasons behind it? Why are tools like Prometheus, Grafana, and Zipkin are not enough?
So they are pretty good tools. So obviously, as I showed, they have very, very good qualities and they can take you a long way. But what we find it starts becoming interesting is, as an organization scales or as your infrastructure scales up, various other what you might think of as peripheral concerns start becoming more and more important. So for example, you may want to be in multiple different clouds, right? You may have multiple different regions that you're deployed in. So then how do you build a strategy, let's say using Prometheus, where you're able to have them all together and still be able to look at all these data holistically? So things like that become harder. Long term, like, so for example, if you're doing capacity planning and such, having these long term trends where, you know, we have people who want to know what happened a year back. They want retention as far back as a year and so on. This is where, because of the Prometheus storage format, it starts becoming a challenge unless you have many instances, and then managing them becomes a problem. Another area we find has to do with just how people will use a monitoring system. For example, if you have 50 teams and one of them makes a mistake and starts sending a whole lot of data, that may bring the whole infrastructure down, or a big part of it down for everybody else. So being able to have quotas is important. When you have a sea of information, how do you make sense of it? Like, if every user goes in and sees everything that's available in a metrics or monitoring system, then they are going to be overwhelmed. So how do you provide better, maybe isolation of the data and so on? How do you have security? How do you push common best practices? Maybe there's a best practice MySQL dashboard that all of your team must use, or for your own services. So as you sort of think about companies scaling up, we find that many other of these concerns become more and more important, and then they will either require, let's say, a vendor solution, or will require a pretty sizable team within the organization to build these for them. So I think it's easy to get started, but then as you mature, as your requirements become more higher level, then you need to spend some serious resources or money on it.
Yeah, that makes sense. I think it's the usual build versus buy dilemma, that the right answer changes on the scale.
Right.
Unfortunately, that's all the time that we have. There are more questions in the Q&A tab, so I hope, guys, you will have time to answer them in writing and send together with the follow-up email. Thank you, everybody, for joining us today. The webinar recording and the slides and the answers for the unanswered questions will be online later today. And we are looking forward to seeing you at the future CNCF webinar. Have a great day.
It was our pleasure. Thank you very much.
Thank you.
Thank you.